Good day, doctor. My name is Jia Qi, and my FYP proposal title is Fabrication of Closed-link Nanofiber Hydroxyapatite Incorporated with Tryptophan and Gelatin. In my presentation later, I will discuss about the introduction, literature review, methodology, and expected results. Let me start with my study background. There are approximately 22.3 million numbers of orthopedic surgery was performed worldwide, and defective bone tissues are the second most transplanted tissues. Before bone tissue engineering is developed, the bone reconstruction is conducted by using a compatible donor's bone tissue or from the patient himself. After bone tissue engineering is introduced, the bone scaffold is fabricated and being used as bone graft for bone healing. There are two problem statements in my study. First is the mechanical properties problem. According to the research, the hydroxyapatite scaffold is brittle. The brittle structure will cause the problem of mechanical loading during the implantation stage and eventually affect the bone regeneration process. So, the solution is hydroxyapatite incorporate with other polymers which are tryptophan and gelatin, and then followed by cross-linking. The second problem is about the porosity. Porosity of scaffold is important because it enables cells migration and exchange of nutrients and waste. Then, the previous developed hydroxyapatite scaffold has shown to have a low porosity structure. Other than materials, the fabrication method is also important to determine the surface morphology of scaffold. So, fabrication of scaffold where electrospinning can help to produce a porous structure. Based on the problem statement just now, the objective of this study is to fabricate the closed-link electrospun nanofiber scaffold at different concentrations of hydroxyapatite incorporated with tryptophan and gelatin. To characterize the physiochemical of the scaffold by using scanning electron microscope, Fourier transform infrared spectroscope, energy dispersive X-ray, and contact angle measurement. Next is literature review. Bone is a mineralized connective tissue that is mainly comprised of minerals, organic compounds, and water. Osteoblasts, osteocytes, and osteoclasts are types of bone cells that are important for bone remodeling. Osteoblasts secrete and synthesize the bone matrix, balancing the calcium and phosphate ions during the bone mineralization phase. Osteocytes send signals to enable bone resorption, regulating mineral deposition and bone formation in skeletal metabolism. Osteoclast is responsible for the degradation or resorption of bone to promote new bone formation. Bone scaffold is a 3D biomaterial that can provide an environment that is similar to the extracellular matrix and promote bone cells regeneration. Hence, properties of biomaterials of the scaffold are vital to ensure can simulate cells' natural behavior with regenerative signals. Metal, bioceramic, natural, and synthetic polymers are the types of material that are usually used in the fabrication of scaffolds. In my study, the biomaterial that I will use is hydroxyapatite, tryptophan, and gelatin. Hydroxyapatite is used because it has high similarity to mineral apatite in the human bone. It is also osteoconductive, biocompatible, non-immunological rejection, and can stimulate the proliferation of osteoblasts by increasing the concentration of calcium ion in the bone. Tryptophan is chosen because of its mutability, biocompatibility, biodegradability, and osteogenic properties. Gelatin is contain RGD sequences that can help to enhance cell adhesion, proliferation, and growth through interaction with integrin, and it is also has good biocompatibility and biodegradability properties. The properties of bone scaffold also need to be optimized to ensure the functionality. First, it is biocompatible, where it is allowing bone cells to adhere to the scaffold surface and proceed with proliferation, differentiation, and finally produce new matrix. The scaffold is degradable to generate space for new tissues. Besides, the degraded product also must be non-toxic. Bond scaffold need to have good mechanical properties to retain its structure to support the cell's growth. Lastly, it should have porous structure and high surface area to enable the migration, attachment, and proliferation of cells. There are several methods to fabricate the bond scaffold, including electrospinning, 3D printing, gas forming, and freeze drying. In my study, I will using the electrospinning in order to produce a porous scaffold. This is my research flowchart. I will do the literature review, preparation of materials, and electrospinning solution. Continue with the electrospinning process to produce scaffold and cross-linking the product. Then finally, we'll do the characterization analysis. There are three main phases in fabricating scaffold. First is preparation of solution. To prepare hydroxyapatite chitosan solution, 12.5% solution of chitosan is dissolved in trifluoroacetic acid. After the complete dissolution, dichloromethane is added into a solution at a volume ratio of 1:4. Then, different concentration of hydroxyapatite is added to the solutions. For hydroxyapatite chitosan gelatin solution, 5% chitosan solution and 15% gelatin solution dissolved separately in a solvent system of TFA and DCM and 70:30 ratio, and then mixed together at a ratio of 50:50. After that, different concentration of hydroxyapatite were added. The electrospinning process is conducted at room temperature. Solution is fed into a 23 gauge needle with a feed rate of 0.15 milliliter per hour and 50 kilowatt. And the distance between the tip of the needle to the collecting place is set at 50 centimeters. The fabricated scaffold are closed-linked by exposing them to vapors of 10 milliliter of 25% butyrate solution in a petri dish. After that, the scaffolds are then placed under a fuel hood to remove the residual. By cross-linking, it can improve the mechanical properties of scaffold. Next is the characterization analysis. The scanning electron microscope is to analyze the surface topography of the scaffold. Fourier transform infrared spectroscope is to identify the existence of specific functional groups in a scaffold. Energy dispersive X-ray is used to identify the types of elements and also determine the concentration of that element in the scaffold. Contact angle measurement determines the hydrophilicity of the surface of the scaffold. And this is my Gantt chart. For the expected result of this study, it is expected that the diameter of nanofiber is increased with the increasing of concentration hydroxyapatite. Besides, they are also predicted to have a porous structure and the pores are interconnected. For the FTIR analysis, both scaffolds will have bond formation between the compounds that present in the scaffold. In EDX analysis, the HN chitosan scaffold is predicted to have space for elements of carbon, oxygen, nitrogen, calcium, and phosphorus elements, while HN chitosan gelatin scaffold has additional peaks for carbon and hydrogen elements. Lastly, bond scaffold will have increased wettability with the increased concentration of HN. That's all from me. Thank you.